We're now going to start discussing thermodynamics with a few basic concepts. First of all, we would like to define the concept of thermal contact. So what do we mean by a thermal contact? If you have two objects A and B are in thermal contact, what does that mean? That means energy in the form of heat, and electromagnetic radiation can be exchanged between them. So basically a thermal contact allows energy exchange between the systems until an equilibrium situation has been reached. So that's the next concept we should talk about, thermal equilibrium. So what do we mean by thermal equilibrium? We take two objects A and B. So let's do that. We take two objects A and B. Here is the thermal contact between them. So this is object A, object B. Because I have a thermal contact here, energy can flow from A to B, or energy can flow from B to A. If we find that there is a thermal contact between A and B, but no net energy flow. In that case, that means equilibrium has been reached, or thermal equilibrium has been reached. No energy exchange in the form of heat or electromagnetic radiation, no net exchange of energy is needed in order to reach thermal equilibrium. Now we're going to discuss a situation where we have a system A is in thermal contact with a system C, and a system B is in thermal contact with a system C separately. So I make a thermal contact between A and C. I find that there is no energy flow, net energy flow between the two. Thermal equilibrium has been reached. And then I make a thermal contact between object B and C. And I see that there is no net energy flow. Thermal equilibrium has been reached. Then these two will imply that if I make a thermal contact between A and B, what would I find? I would find that A and B are in thermal equilibrium. So we can show that here I contact A with a system C, and system C is measuring a number which I call temperature, 22.5. And then I contact with B, system C with B, and I measure the same number, 22.5. And when I make a contact between these two, they will be in equilibrium. So this number that I'm reading here is called temperature. And basically a temperature concept tells me how far from thermal equilibrium a system is with respect to a reference system. It's the property that measures how far from thermal equilibrium a system is with respect to a reference system. For example, I say that the temperature of icy water is 0 degrees Celsius. Then if I measure the temperature of this system A with this probe C and find that the thermal equilibrium is reached at 22.5 degrees C, which means the temperature of A is now 22.5 degrees C. That means I'm a little far from thermal equilibrium with icy water. If I were to make a thermal contact with icy water, then energy would flow from A to icy water in order to reach thermal equilibrium. If this number is 100 degrees C, that means I'm quite far from thermal equilibrium, a lot farther from thermal equilibrium with icy water. So we're going to talk about temperature scales and what they really mean in the next video. But basically, I would like to conclude by saying that if you look at the temperature of system A and you find that it is equal to the temperature of system C, and temperature B is equal to the temperature of system C, this means A and C are in thermal equilibrium, B and C are in thermal equilibrium. This means we can conclude that temperature of A is equal to temperature of B. If we were to make a thermal contact between A and B, they would be in thermal equilibrium. So what I have just stated here is the zeroth law of thermodynamics. So zeroth law of thermodynamics defines temperature, and it's just saying that if two systems have the same temperature, when they are made into thermal contact with each other, there would be no energy flow in the form of heat and electromagnetic radiation between the systems.